output. It's 60. Okay. If you can, Yasser, hey, good to see you. All right, let me know what platform you're watching from. So I know who's coming from where and what's working and what's not before we get started. So Yasser, it looks like you're on YouTube. Even though YouTube's saying we got an error, LinkedIn says it's sending data. Sounds like it's thinking about it. Right. Right, and I have no idea how much of a delay I'm on either. Shoaib, great. Looks like you're joining in from LinkedIn. Okay. Let me just do a network connection test, see if that's a problem. I should be really jamming on network speed, so. Looks like 300 megs down. Well, we'll give it a minute, see if it stabilizes out. Again, thanks so much for joining. First time I'm doing this. I'm using a new service to restream to multiple platforms, seeing how it works. Yeah, I'm showing like 200 megs upload, so bandwidth should not be a problem. But let's just see. YouTube seems to be better. Okay. Sai, if you're having streaming issues on LinkedIn, sounds like YouTube is the better spot for that. And which funny enough, my YouTube shows that like the stream hasn't started yet. So hopefully we're all good and we can jump right into what I wanted to cover today without too many technical difficulties. Again, thanks so much for joining. Yeah, it looks like we got LinkedIn, YouTube. And yeah, sweet. And oh, one more I wanted to check. It should be streaming on X as well, but we'll see. And I also don't know what the delay is that we're experiencing. All right. It does look like it's also streaming on X. So lots of options there. Okay, cool. Well, again, just shoot me in the comments if we're having streaming issues. I apologize if we are. I'll do another test stream on this later and really mess around with it to see what issues might be going on. But thanks again for joining. What we're going to talk about today, first of all, let me just kind of explain what I'm doing here. I'm starting this. I started this blog. Well, I don't know. It's been a while. Production ESP32 to talk about all things ESP32 in production. So using ESP32 in commercial products, not just makers, although makers are more than welcome to join the stream and learn some stuff. But the content here is really going to be focused on stuff around using the ESP32 in a production environment and some of the things that you run into when you do that. I've gone through that now with several products and just lessons learned, and I want to start sharing that and have started sharing that here on the blog. So you can check this out. There's a newsletter you can subscribe to if you're interested and get updates there. So what I want to talk about today, though, I'm going to move all these streaming windows up, is, let me just drag this across, is my setup. This is the development setup that I use personally on multiple production ESP32 projects and products that I found to work very well and is, like I say, it's worked well for me in production settings. So again, if I could just get a thumbs up from everybody that's still here in the chat so I can see, make sure that this is streaming and I'm not just talking into the void, Yasser, you still there? Shoaib, Sal, if you want to just give me a thumbs up, thumbs down on audio quality. I don't want to go too much into this if people are not able to see the stream. So let me give that a second. It looks like we're pretty behind on the stream. If I'm looking at this right on Restream, I'm using Restream for anybody that's interested. Looks like I'm a good ways behind on that. Okay, well, as I'm going through this, if you have any questions, throw them in. Like I said, it looks like I'm maybe up to like a minute delayed on the stream here. So if I don't answer you right away, it's probably just because I haven't seen it or gotten that, or you haven't gotten to where I'm at yet. So bear with me again. So, okay, so let's talk about my setup here. So first thing that you'll notice, I'm using VS Code. Now, I prefer VS Code. I'll share throughout the stream here a couple of things that I really like about it, but it has risen to the top of code editors. Doesn't mean it's the only and correct solution. I don't believe in that. Use whatever you think works for you, but everything I'll be doing on the stream will be done in VS Code just because of the tooling that's in place and the integrations that exist. I found it's extremely helpful in a production development environment. And so, plug for VS Code, use it if you like it. If you don't, I don't know how useful this will be because there's a tight integration here about what I'm going to talk about. And so, the second thing that you'll notice is that this is raw ESP-IDF. One of the things that I've talked a lot about in the community is this idea of Arduino IDE versus PlatformIO versus ESP-IDF, and there's a lot of opinions about all of that. However, the reason I advocate for ESP-IDF is because it is the straight raw SDK from Espressif for the ESP32 family of chips. And so there's no abstraction layer above that you have to deal with, which is something that I have seen consistently people struggle with. With Arduino, there's a huge library ecosystem and community, which is great. But in the Arduino IDE, you are locked to a lot of decisions that they have made for you in regards to how you can use Espressif's SDK, the IDF. And so they have made a bunch of those decisions for you, and they've exposed a few of the things that you can change setting-wise, but nowhere near, maybe less than 5%, probably even lower than that, of all of the options that you have available from the ESP-IDF. And so I highly recommend to anybody starting a product, especially one that's going to production, use the raw ESP-IDF. I'll do some streams later about how that is not very scary, and I'll talk about that here for just a minute. But a lot of people get, oh, that seems really scary. IDF seems really low level. It's actually not. The setup is really, really easy. And I will drop a link in the chat here. Let's do that, testing the chat, to the project that I'm using here. So let's go. Let me just bring that up. Actually, you know what? I can show you what I'm doing here. We're going to go to github.com/fleet. And we're going to look at this, yeah, right here, SDK. So I've got a service I run, Deploy the Fleet, for OTA updates. I have this playground, which allows you to evaluate it. But the raw project itself is just a very, very simple, very plain, empty ESP-IDF project that we can use an example. So I'm going to take that and I will drop it in the chat. See how that works. Hit send. And it doesn't seem like it wants to send. Okay. And Let's just check on channels. Okay. All right, and chat doesn't seem to be working great either. Trying to send that. Well, let me just come back down and show it to you again. Again, we're working through the bugs. We'll get there. First episode to be expected. Okay, so it's just github.com/deploy_the fleet/DTF_SDK_playground, and that's the code base that we're working in out of this today. So, okay, so and this is extremely simple. We've got an app main here. This is the entirety of the code. I do have if you clone this, you'll see that there's a DTF SDK in the components. Don't worry about that at all. It doesn't matter. We're not using that. This is the entirety of the program that we'll be looking at. And so, not as scary. It looks a lot like an Arduino program if that's all you've ever been familiar with. And really, it's just a single function. In Arduino, you're used to setup and loop. Right here we have app main, but this could really be broken up into two functions, which this top part here is the setup. You could break this out and call the function setup and then call it here if you wanted to. And then this is really the main down here. We have a, if for Wi-Fi, this actually could go up into setup as well. And then this while loop is what would be the main that just runs over and over and over again. And so, again, highly recommend ESP-IDF. It's not as scary as you think or you've been told. And it opens up the entire spectrum of things that you can do with the ESP32 family of devices, and you're not limited. Just a brief mention of PlatformIO. I know a lot of people love that and recommend that. I have not used it a lot. I used it in one project that I consulted for a couple of years ago, and it's fine. I understand why people like to use it. Again, it does put an abstraction layer over top of the IDF, and a lot of the problems I've seen people have to deal with is something's not ready or hasn't been ported or downstreamed into PlatformIO that they then have to figure out. I highly recommend take the small learning curve, go through it, get into ESP-IDF. You have no other dependencies or abstractions that you have to work through. It's just the raw code. So, okay. VS Code, ESP-IDF. Now, the core idea that I use for my development environment are Docker containers and images. So if you're not familiar with Docker, I highly recommend you spend some time. It is a industry skill that you will not regret gaining. And the idea here, for those that aren't familiar with Docker, is it's kind of like a virtual machine, although that's not quite an apples to apples comparison, but it allows you to create an environment that is separate from your main machine that's running and run things in what's called a container. And so you're in basically an isolated environment where you can run different services, play with different technologies. And in this case, in VS Code, they have a really cool integration that's called VS Code dev containers. And so paired with Docker, you're able to create this sandboxed area for development. And that's really powerful for a few reasons. One, I don't have anything related to ESP32 or Espressif installed on my main development machine. There is nothing locally installed. Everything I do is done via a Docker container through dev containers. And so that really eliminates a whole class of problems when you're in production and you have a team of developers. It eliminates the entire class of problems of it works on my machine, or what's different about your ESP-IDF installation than mine, and why does mine work and yours isn't, what settings are there, and what version of the tools do you have. All of that goes away if you use Docker containers, because it codifies your setup, so it is fixed across everybody on the team. And that's not as powerful when you're a single developer, although I will show you some things that's helpful for. Extremely powerful when you have a group of developers. At a previous company, as head of engineering, I was able to onboard people in about 20 to 30 minutes on all of the development environment. And that is an incredible productivity boost. Sometimes that can take days and you're back and forth depending on if you're a distributed team or not. And so with this dev container setup that I'm going to show you, setup is extremely simple, very fast, and anybody that joins the team is immediately up to speed on what the environment looks like and can start coding, building and flashing on devices. So that's why I recommend that. Okay, so let's talk about two important concepts from Docker. Just as a quick rehash, this isn't a stream about Docker, but I just want to go over it. There's two main terms that you'll hear in Docker: images and containers. An image is basically an instruction file or blob of this is the computer that you will be working with, the computer image that you would be working with. And a container is actually a running version of that. And so from a single image, you can create multiple containers. And the image is that sort of baseline setup that contains all of your dependencies. And so let's just look at that really quick here. I wish chat was working because then I'd be able to know if this is big enough for people to see. So I apologize if the font is small. I'll be collecting feedback after this is all done. Again, I appreciate your patience. Okay, so two files here, Dockerfile, devcontainer.json. Let's first look at, and these are all in a folder called .devcontainer. This is all part of the repository that I linked, so you can check it out there. But in devcontainer.json, sorry, we're going to look at that next. Dockerfile. The Dockerfile, this is your instruction set of how you want your environment set up. And so let's just go through it really quick. Again, I don't want this to be a tutorial on Docker. You can do a lot of research on that. You can copy this out of the repo, drop it into Claude or ChatGPT or whatever your favorite AI model is and say, explain this Docker file to me, and it'll give you a much better version of that than I can probably produce. So we've got some arguments up here. This Debian front end non-interactive allows us to do installation headless without user interaction. This user ID is really important on Linux. I am running on Linux. The instructions are almost identical on Mac, and you're going to run into some hurdles on Windows, but it's not impossible. And so this user ID helps me map my local Linux user into the containers that I'll be using. And then this is the really most important first part of this Docker file, which is from Debian Bookworm Slim. And so we are crafting our image for development from Debian Bookworm. And the Slim is we're using a pared down version of that. We don't need the full Debian OS for what we're going to be doing, which is developing on ESP32. This is just some more. We're passing, make sure these args, it says import global arguments from up here. You can pass these in as arguments, which we'll see in a minute. And then if you are not familiar with Linux, this is probably going to make you gloss over, and that's okay. Just know that this is adding a local user to our running container for development that we can run under. So a lot of times you'll run Docker containers as root, which is fine because you're in a sandbox and it doesn't matter that you're the root admin user. But in the case of ESP32 development, there's some tooling and things like that we want to make sure we're running as an actual user. And so that's what sets this up. We set up a user that I'll show you the name of in a minute, and that's how we enable that. Okay, next up, step 1, install prerequisites. So these are just Linux commands. These are just how you would run apt install to install all of the dependencies that you need. And so I've gone through the trouble of figuring this out. These are the bare minimum set of dependencies that you need to run the Espressif ESP-IDF on a Linux machine, as well as some extra things that I like. So if there's any command line utilities that you want to have access to while you're in the development environment, you would add them here. So a couple of the ones that I added, GNUPG. This allows me to sign my commits right from inside VS Code. And so I have signed commits for everything. And then a couple of these like wget, xxd, these are just little utilities that I occasionally want to have access to. Remember, when you are developing in a dev container, you do not have access to any of the tools that are available from a command line on your main machine. So if you open a terminal on your main machine and you can do curl, that's probably not in your dev container unless it's part of like Build Essential or some of these other things. And so if you want it to be available, that's not a problem. You just have to add it to this list of things that you have installed dependency-wise. Oh, excellent. Trabe, thanks for confirming chat's still working. I will increase the font size. Okay, so that's dependencies. And then we're going to do get ESP-IDF. And so what we're doing here, and there's two schools of thought. There is an extension in VS Code for ESP-IDF. I will play with that more. I actually don't personally use it in my development environment, and I'll show you that in a minute because I don't really need it. But there may be some cool features there that you could have, and that's not a problem. You can install that as a dependency in the dev container, which I'll show you in a minute. But for the purpose of the Dockerfile, we are just installing ESP-IDF raw, and we just clone it directly from GitHub as you might install it on your local machine. And there's a couple of important things to note here that are the production side of this and not the I'm just messing around as a maker. And that is how we are cloning and checking out a commit. So you'll see I'm actually a little behind current stable on this, which I'll update. If we have time, I'll do it on the stream here. But I'm cloning the 5.4 branch of IDF recursive. So I need all of the submodules that are associated with that just from the ESP-IDF Git repo. And then I'm putting that in my IDF folder. That's probably how you might do it on your local machine. The second part of this is the very important one. I CD into the IDF folder, and then I check out a specific commit. This is extremely important. The IDF is not branch stable, meaning if you just check out this branch, this has happened to me multiple times, and that's why I do this nowadays, is that branch could become unstable. They don't do it on purpose, but there are commits added. And so when you check out branch 5.4 today and branch 5.4 in 2 weeks, you are going to get different code as far as ESP-IDF is concerned. Now, typically that's not a problem. Sometimes it is. I have experienced where on the same branch, major release branch, there have been breaking changes. And so a teammate will clone this project, try to build, and get an error. Or worse, it'll compile, but you'll have a crash because they introduced a breaking change that you have not tested. The way you get around that is git checkout a specific commit. So not only am I checking out branch 5.4 of the IDF, I am locking to a specific point in time. And so I know for sure in my development environment that that is never going to change. And that is incredibly powerful for teams because you will not have to debug a whole class of bugs of, well, your IDF is slightly different or 5 commits ahead of mine, even though it shouldn't matter. I promise you it does. And so you definitely want to do this. And then when you're ready to move forward, maybe just to a different commit on the same branch, you can do that and you can evaluate all of the changes that happen and assess risk of are any of these changes likely to affect our product. And same thing when you want to do a major version bump or subversion here. If you want to do 5.5, you'll pick a commit. Normally it'll just be the tip. So you can do your testing and then you're locked to it. So you don't have to worry about any PRs coming into that branch and breaking your stuff. Okay, next up. I have this all commented out, but I've left it in here because I have used this on multiple projects, and that is applying IDF patches. When you get deep into a product and you're pushing the very edges of IDF, you will find that you're hitting the edges sometimes of IDF and you're opening issues, and they may want you to try a patch. I've had this, as you can see, BT. I found a Bluetooth issue, and as they were working with me through the issue on GitHub, they asked that I apply a patch. And sometimes you have to do that for a while until the patch gets mainlined and approved. But if it gets you over a hurdle, you'll want to include it. Again, this is where local setup. You don't want to have to go to every member of your dev team and say, hey, this is how you install this patch, and here are the git commands. It's all built into the image and therefore the dev environment container. And so I left this here as just an example of how you would do that. And I have in the past. It's awesome, and it makes your environment the same across all of your development team. Okay, finally, this is setting up the tools. This is just straight from the IDF installation instructions. You need to install, the ELF, the linker, the compiler, all the ESP32 versions of that, and that's what this does. And then the very special sauce here at the end is this run echo source. This is a Linux command that if you've run the IDF before on Linux, sometimes you realize you have to run this export.sh, which is what primes like a bunch of environment variables and make sure everything, the paths are all correct. This does that for us so that when we're in our dev container, we have access to all the tools, which I will show in just a minute. Okay, we're doing okay on time. I'd like to be doing a little ahead of where we are. These last two are just things that when you install IDF in a container like this, there were some complaints about language environments not being set because, again, it is a raw Linux environment. These are normally set on your machine, and so we just set them inside of our image so that they'll be in our container. Okay, let's take a look at devcontainer.json. We give it a name, and so this name is what tells me what IDF version I'm in. That's how I like to name them. And so that down here in this corner, it's really small, and I'm sorry, hopefully you can see that. But you can see the name is what displays right here, ESP-IDF 5.4. So I can know just at a glance, the current code base that I'm working on is using a 5.4 image. Now, there's nothing that will stop you from writing 4. Something, even though your image is 5. But just make sure that those are kept in sync. For the build, we're saying use the Dockerfile that we just looked at. And then here's where I'm passing in that args, user arg of dev. So my user inside of the container, the dev container, is not root or Kevin, it's dev. So that's where, home/dev, all that. And you can name this whatever you want. It doesn't really matter. These are just my VS Code optimizations that I like to have for making the experience better in the terminal, because I do everything from the terminal in the dev container, which I'll show you here in a minute. Extensions. So when you run dev containers in VS Code, you can install extensions into VS Code itself globally, and then you can install extensions at the container level. Because remember, once you're in a dev container, it's like you're on a completely separate computer. And so you can install completely different dependencies within that than you do in your main VS Code, which is also really handy because for some projects you might need certain tools and in other projects you wouldn't. And so you can just install the extensions that matter depending on the project that you're working on. Okay, now let's talk about, this is just stuff I figured out that you have to have. Okay, last thing here, and this is where Linux, Mac, Windows, they're all different. I personally prefer Linux for embedded development, to each their own. One of the things you get with Linux out of the box, no extra hassle, and it's amazing, is adding your device directly into. So what I'm able to do is I have for this, just so you can see, I'm using a ESP DevKit 3 or a DevKit C. I have that plugged into my USB port. And I know that it will enumerate as TTY USB 0, and I can essentially plug that into my dev container so that I have access to it just like it's a local device, which allows me to flash and monitor. That is also doable on Mac. I'm not gonna lie, Windows users, it's rough going. Like, there's ways to do it. It's complicated, and you got to use virtual machines. I don't know if it's gotten any better. I haven't tried it in like a year or so, but last time I tried it, it was a bit of a hassle. You can do everything else in the dev container on Windows, just like I'm showing today, except for flash and monitor. You would have to do that outside and install any dependencies for that on your local Windows machine. So this is super, super cool and allows you to essentially mount your device into the container. And then here's that remote user. I'm saying I will be the dev user when I'm in the container. Now, what does that look like? Okay, I'm gonna open the terminal here. And now you'll see in this terminal, hopefully that's big enough you can see, I'm dev at, and it's just this like image hash, but I'm user dev. This is not, I could run remove -r-f root drive, and it will not have any effect whatsoever on my actual machine that I am running on right now. And so that is, again, one of the things I love about doing dev container development. You are in an isolated, as far as you're concerned, completely separate development computer than the one that you're running on, and it's really handy. But right out of the gate, I can do idf.py version, and you'll see that I'm running IDF 5.4. Now, really quick, let's go back to the Dockerfile. Let's say I want to change to 5.5. All I have to do is come over to here, change the branch to 5.5, change my checkout commit. I would come into the Docker container, change the name here, and then it will go through a one-time build, depending on your internet connection and things like that. It will build that image for a new dev container, and then you're set. And then once you have it, you can switch between versions of IDF just by switching images. Like, it's very, very fast. So you can have simultaneously, if you're working on multiple projects, you can be in 4.4 of IDF, 5.2, 5.5. You can have a container that's running the new 6 and get early access to that. You don't have to manage any of that on your local machine and remember where you're putting folders or change paths or anything like that. You simply open up the container using the image in VS Code, and you can switch between versions of IDF. Extremely powerful, especially if you're doing contract work. You can be on the exact right version of all the different projects that you're working on without messing with your local machine at all. Extremely powerful. Okay, and now what I'm going to do is I'm going to turn that on, and I'm going to do idf.py monitor. And it's not idf.ply, it's idf.py. Okay, and here you go. Like, again, I have my dev kit here. Again, just this little guy mounted into the dev container, and I can do idf.py monitor and see the output of this program right here that we are running. So let's do current version. Let's just make a change here. I'll show you that really quick. Current firmware version. Hello from Production ESP32. Okay, and again, you're used to, if you're used to Arduino or things like that, you might have fancy buttons. It's really not that big of a deal. You have to have a flash monitor. This is my bread and butter if I'm doing rapid development. This will build first, and if there's any errors, it will stop. Let's actually show that. Let's get rid of this semicolon there. So now we have a compiling error, but I'm going to do flash monitor. I'm going to hit enter. It's going to think about it, and it's going to be like, I can't do that. You have an error. And it'll tell you get the errors here. You can, from the terminal here, you can click, control click. It'll take you to the line of code. Super helpful. All the great things you get with an IDE that you, all these things you're not going to get with the Arduino IDE, I can tell you that. All right, and we'll save it. And now let's try to run it again after we fixed our compiler error. We can ignore the warning because I'm not doing anything, like I said, with the deploy the fleet library, but I left the struct in here. Okay, so it's going to build and flash, and we should see this hello from Production ESP32 come out the other end. Once it connects to Wi-Fi. That's the other nice thing that's in this GitHub repo, if you want to clone it and use it for your own testing, is it's got this little Wi-Fi connect that you just provide it a username and password, and you get Wi-Fi connectivity, so you're not messing around with that. It's just kind of a little helpful thing. All right, and so here you go. Hello from Production ESP32. So great, it's working. Okay, what else do we get with this? Oh, this is one of my favorite things. All right, so let's come back up here, and this is where the power of having everything in an IDE like VS Code really starts to shine versus the Arduino IDE. And that is because the environment is set up and strictly controlled via this Docker container, all the dependencies are installed and allows us to do full code search. And so I'm going to get rid of the terminal here. And let's just say we have this connect to Wi-Fi. I can right click on this and I can go to definition. And it's going to take me to connect to Wi-Fi. Great. Connect to Wi-Fi is just in the same directory here. It's just right next door to main.cpp. But, and I have a Vim extension installed, so that's how I like to navigate code, kind of with the Vim keys. And so I'm going to do that. The equivalent for that in Vim is GD, go to definition. So let's just say I'm curious about how some of this stuff in the IDF works. So like ESP Wi-Fi init is an IDF function. That's not code that I wrote. So I'm going to hit GD here, and it's going to take me there. And you'll see up in here in the editor, if we hover over this, that's going to be really small for you people watching on the stream, so I apologize for that. But I'm in the home directory, ESP-IDF components, ESP Wi-Fi source, Wi-Fi init.c. And so this is the IDF code itself, and we can go as far down this stack as we want just by doing go to definition. This is incredibly useful if you are trying to learn how IDF itself does certain things. I've run into bugs over the years where it's very easy to just come in here and make changes. Again, if you make changes to this, you're only changing the IDF environment in this dev container. It's not the image that you're changing it in, so any other projects that use that same Docker file won't be affected, but it's just in this. So it's really powerful for you to mess around and make changes, like I say, with exploring stuff with the IDF. If you want to add additional logging, you can do that. I don't know, let's just play around and see if ESP log is in here. ESP log E. We'll say prod ESP32. This is from down in the IDF. Okay. I don't know. Let's just see if that works. Logging might not be. Yeah, okay. Sweet. Looks like it is. So let's see what we get. Let that build. Sal, awesome. You're going to get my awesome like 5 minutes afterwards because apparently the stream delay is terrible, but that's awesome that you got IDF with VS Code and Docker set up. It's really not bad. It's scary to a lot of people, but really not bad at all. Okay, let's come back up here. Did we get our... you know what? We're not going to have logging turned on for this prod ESP32. So let's change this to main. Flash monitor. Okay, let me look and see what else I want to talk about. Yeah, okay, so we've got about 20 minutes left. Let's see if we can update this to 5.5 just as a to show you how we would do that. One of the gotchas I already talked about on this, which is Windows. Sorry, Windows users, there's going to be some issues there, but not insurmountable. So stick with it. Let's see. I don't feel like I'm seeing my error log out here, so I'm not sure why that's not coming out of. Let's do idf.py full clean. Should see that. There's probably a log level thing that I've messed up. Oh, do I here? Let me just check this really quick. Sorry. I think I'm overriding. Well, it should log everything info and up. So that shouldn't be it. Okay, did we get it that time? If not, we're going to move on. Probably just a log setting somewhere. Okay. So let's, so I talked about Windows. Oh, I'm going to reopen this locally. So you can reopen this folder locally. So we'll do that. Now, in VS Code, when I do that, it thinks it's a completely new environment. That's why I get all these messages of like there's updates and things. Now, if I open a command prompt, I'm on my local machine. Like I can mess up things. I can run things I have installed locally. And I'm no longer in the dev environment. In fact, let me open a terminal here. You can see now I'm at Kevin at Pop! OS and I'm in the playground thing. But if I do idf.py version here, it's going to say I have no idea what idf.py is. And that's because, like I said earlier, I do not have anything from the IDF installed on my local machine. I do everything via dev containers. Now, I'm going to turn off my dev kit here. So it's unplugged. You can see there's no lights on it now. And so it's, as far as my system's concerned, it's unplugged from USB. And now what I'm going to do is I'm going to say reopen in container. And so I'm going to get an error right out of the gate. And the reason I'm going to get this, we can do edit dev container.json locally. These files can be a little cryptic. Let's move this over so it's full size. But right here, you can see the error says response from daemon, error gathering device info while adding custom device dev TTY USB 0. So when you first launch the dev container through VS Code and you have a device mounted, again, like I do here in my dev container.json, this device needs to be present only when the container is launched. You can unplug it afterwards and plug it back in. That'll all work, and let's just show that. So what I'm going to do is I'm going to turn it back on so it's plugged back in now. And now I'm going to say reopen in container. And now we're back. You're going to see it's activating ESP-IDF 5.4. We're back in a state here where I can do idf.py -- version. And I get, now you'll see it says -dirty. Why does it say dirty? Because I made that change. Remember that logging change over here in Wi-Fi and it's C. So I'm in a dirty, I've modified the IDF. So that's really handy just as a tip there if you do version, if you've made any changes to the IDF. Okay, and so now I'm back to being able to monitor, but now I'm gonna unplug my device there. Yes, unplugged. And I'm gonna do idf.py monitor. And it's gonna say there's no serial port available. And so again, you have to be plugged in to start the container, but then you're welcome to unplug and plug and do all that. Once the container is open, it doesn't matter at all. So that's just something to be aware of. So I'll plug it back in now. And we'll go back to monitor. And you'll see it'll just connect right back up. And you'll get your output down here. So cool. We have like 12 minutes left. And again, I apologize for the technical difficulties. It looks like streaming is struggling. I will mess around with all the settings on that. And hopefully we'll have a better experience next time around. Looks like things are still streaming on X. X seems to be the best at picking up this stream from Restream. So again, my apologies to anybody experiencing technical difficulties. Refresh this and see what I get. Okay, cool. Since we have a little bit of time left, if there's any questions, I don't know how I would get them because, again, chat seems to be broken. Let me just refresh YouTube and see what I get. Yeah, okay. All right. Well, let's use the remainder of the time here productively to show how we would upgrade. Recently, IDF released version 5.4. So let's take a look at that. It's not 5.4, 5.5. So let's do github.com/espresso/IDF, ESP-IDF. Okay, and if we come over here to releases, you can see 2 weeks ago they released version 5.5. So I'm going to look at that. And then here's the latest commit hash right here. So I'm going to click on that. And yeah, here we go. Copy full SHA for this commit. So I'm going to do that. And then what I'm going to do is I'm going to come up here. First thing I'm going to do is come into my, I don't want to forget to name it. So let's rename this. This is now going to be version 5.5 in our container. Let's get this to stop spamming us and close that. Okay, no other changes in the dev container.json, but in the Dockerfile, now we need to say, hey, instead of cloning 5.4, we're going to clone branch 5.5. Now, this hash is no longer correct, doesn't exist. So I'm going to take that out, and I just copied the other one, that 8C75. If we come back down here, you can see 8C75 0B0. Great. This can take a while, so let's get it started and see how we're doing. But I'm going to save that. Now, when you save that, sometimes you get a little message here in VS Code that says you need to rebuild the container. But otherwise, if you just click down here, you'll get a menu. You get this option of rebuild container. And so we'll go ahead and click that. And what that's going to do is it's going to say what changed in the Docker image, because it builds this in stages. And so Docker will figure out how much of this Docker file do I already have of a record of, and which changes did you make, and how can I, it does a whole bunch of things to be helpful and be efficient. and we can click right here and show the log. And you'll see right now I'm in this cloning IDF right here. It's very bottom. It's probably small in the stream. I apologize for that. But right now it is running that clone. Now this does, every day it takes longer for IDF to clone because they're adding more code and more submodules. And this is doing a full recursive clone of all the submodules. So this can take, depending on your network connection, this can take half an hour if you've got slow network. Typically for me, I think it's about 5 minutes or so. So we'll kind of hang out on the stream here, maybe look through a few other things while that's cloning. And that should be it. So hopefully if this finishes before the stream ends here in 13 minutes, I'll show you when you come up into that dev container, you will be in IDF version 5.5 and you're ready to go. Again, it's like a brand new computer that's running a fresh IDF 5.5. And so that's how you do that. And then again, you can pin that to any commit that you want based on what you need at your company and on your project. So, all right, let me come back to Restream and see. Yeah, not impressed with Restream. I assume people are seeing this, but it's just showing me error. Shoaib is over on X. Yes, X does seem to be better, less delay than YouTube, smoother. Power management tests. Yes, for the so I bought it specifically for a project that I am consulting on, and so I can do that. But no, I have not done the test that you asked for, Shoaib. I have not gotten to that yet. Future stream. As soon as we can figure out all the bugs on this, we will stream about this. And for those that don't know what I'm talking about, I don't think I'm gonna be able to. I don't know. Let's try. Let's see if we can get this into frame here. Coming in. There it is. I got a new toy. I got the Jewel Scope to be able to do very low power testing. I want to do, for these streams specifically, actually, I want to do a whole bunch of testing around low power sleep modes, see what some of the different ESP32 chips. I bought every variant of the ESP32 that I could find a dev kit for. So I've got the S2, S3, H2, C6. I don't think I have a P4, but anyway, I went on like a huge shopping spree and bought all that stuff. Have I tried Streamlabs? Yeah, Streamlabs is just built on top of OBS, so it's just a layer. Maybe that would help. I don't know. I'll try and do another stream off hours sometime and just goof around and test. So yeah, apparently X is the place to be for this stream. All the other ones are struggling. And so I'll have to figure out Restreams. One-click setup for all the platforms in Restream is not working as well as I would hope. And I'm also curious why I can't see the stream on YouTube. Maybe I can. Let me click this. Oh. Yeah, all right, there I am. Sweet. Yeah, and geez, and here are all the comments that are also not passing over to Restream. I'm sorry, guys. I'm so sorry. Like, I was supposed to be getting all of these. One of Restream's marketing things is get all of your updates and chat in one window and stream to multiple platforms, do the chat in one thing. I have not seen any of these comments from YouTube. So let me just go back through these. Good to see everybody. Thanks everybody for joining. We did increase the editor font size. Hopefully that was better. Okay, and yes, I am still using Pop! OS as my main daily driver. And Battle for Your Brain, I'm not sure. Will SDR with ML or I should be able to identify and disrupt these WBAN IoT systems? Jeez, that's a deep question. I don't know. Yeah, that's a good question. I mean, they're all built on top of some. On the ESP32, you're just talking about Wi-Fi. They do Wi-Fi 6 now on the newer chips, and and Bluetooth. And so whatever class of attacks you'd be able to come up with that using RF signal analysis, yeah, I mean the ESP32s would be subject to that as well. So that was a deep question. And let me come back over here. Let's see how far we're back over here on the build and compile. You can see it. There are a lot of submodules for IDF, like everything. CJSON's a submodule. The IP stack is a submodule. Embed TLS is a submodule. MQTT is a sub. All of these things are submodules, which is great because the code is organized as components, but also a lot of cloning to do. One thing that I can't show right now, because when you're building these dev containers, you're in this weird, like you can, I don't know if you can see this kind of progress going back and forth here. I can't actually view the project files, but one of the things that, oh, we're on the stage of installing tools now, so that's good. Oh, Sal, ULP, you want to know about ULP? Like, hit me up on whatever platform. I have gone deep on that. And so if you're stuck or you're having issues or you have any questions, let me know. I've done a bunch on ULP. Happy to do streams on it. I've been putting that out into the wild lately, and it doesn't seem like people have been super interested in it because it is a very niche part of the ESP32. But definitely, if you've got questions on ULP or if you're stuck on something, I might be of help because I've gone deep on that and encountered a whole bunch of problems and solved a whole bunch of problems. And so really cool stuff though. For those that don't know, ULP, ultra low processor, coprocessor on some ESP32 packages that allow you to do deep sleep on the ESP32 main chip, and then the ULP is running in a super low power mode, doing periodic like sensor readings or other things like that. It's got very limited capabilities, but extremely low power, and then can wake up the main ESP32 chip for things like the simplest example was a temperature sensor where, you know, the ESP32 can be in shutdown mode until you hit a certain threshold that the ULP is tracking. And then when it hits that threshold, it can say, hey, main ESP32, wake up, connect to Wi-Fi, alert people, send readings, stuff like that. So, cool. Okay, it looks like we are in now, just in time before we end this up. So we got all the way to the end. Everything was successfully installed. I'm now in the dev container. We can close this and reopen it. And exactly what we were hoping to see. We are now activating the ESP-IDF 5.5 environment. And if we run idf.py/version now, exactly what we were hoping. Notice, the dirty is gone. So those changes that I made in the other container, the dev container, where I was messing around with the Wi-Fi init, those are now gone. Like that computer was basically burned to the ground and deleted because I've changed my dev container setup here for this project to be this new container. And so now I'm back in a perfectly clean IDF, fresh out of the box 5.5 state, and I can start developing on that. Good question, Choi. Actually, Puck Product does not do anything on ULP. The hardware predates that. I don't have that. The room module I'm using that does not have ULP, and so it's doing old school, just deep sleep, and but I still get really decent battery life out of that. Good call out. Okay, well, I think that's all I really wanted to cover. Let me just look at my notes for everything. Oh, last thing, we got just a few minutes before we close out here. Couple things, actually, before I do that. Let's come back over here to Production ESP32. If you're not subscribed to the newsletter and you want to get these, it's a once a week. I do not spam you, and it's related directly to things on ESP32 and around ESP32 production development. I've got this vote for the next stream page here, which has just some ideas that I have. There's not many, as you can see. I kind of just seeded the list, but you can come in here and vote for stuff that you want to see on the stream. So far, Flash encryption seems to be winning. So on Wednesday, that's what I am planning on starting. That's what I'll stream about on Wednesday. If you want to join for that, we're going to be talking about Flash encryption, like why why you care, what things it helps with, and I'm still working on the show notes for that, but all things Flash encryption will probably be the next at least 2 streams, maybe more, depending on what people are interested and have questions about. And again, I have this, if it's not in the list, you can send me an email, support@productionesp32.com. I'm happy to add other ideas so that you can come and upvote this. What I really want to do is I've got 4 million ideas of things I want to stream about, but I'd rather ask, the people that are watching and care what they want to see to bubble up to the top, so it can sort that list for me. So check that out. Again, we will be back on Wednesday, same time, 10 a.m. Mountain, to go over some stuff. Last thing I want to show you was 2 things. Components. This is just an IDF thing. If you're coming over from Arduino, this is your libraries. If you have libraries, everybody's like, I love Arduino because there's libraries. You can actually, in many cases, copy the library straight over from your Arduino environment into your IDF environment with a few tweaks. But that's where they go under components. It's all under one roof. You can see it there. So just a kind of an FYI. And then the last thing I want to show is this extension. So again, I'm in a dev container here, and VS Code will show me locally installed, dev container installed. You can see locally, all I have is dev containers. I've got the Vim extension, and I've got Copilot and Thunder Client. That's all I have globally installed. In the dev container, however, for development, I've got the C++ IntelliSense, CMake. I've got Copilot there as well. I've got this hex editor, which is super nice. So like if I come over here to my build folder, and let's just find the the bin file here. If I click on this, it'll say, this file is not displayed because it's either binary or uses an unsupported text encoding. I can say open anyway. And because I have the hex editor extension installed in the dev container, I can do hex editor, and it'll open that up, and you can actually see, the actual contents of the binary file in hex over here on the side. This is actually really handy for flashing partitions and things like that if you want to check for data, factory data. And so you can install any extensions that are available in VS Code, you can install in your dev container, and then they're isolated just to, again, that development environment. So that was just one other thing I wanted to show. Okay, we are at time here. Again, I want to thank everybody that has joined. I really appreciate your patience with the technical issues. I will be looking into those to try and address those. Maybe canceling my restream. I'll figure out why that didn't work the way that I wanted it to. But we will be back on Wednesday, hopefully with a better stream experience. It'll be LinkedIn, LinkedIn, YouTube, and X is where I'll have it for now. I'm also working on a Facebook group that hopefully will get set up eventually as well that I can stream into. Anyway, I'm just playing around, figure out what works, what doesn't work. I appreciate all the feedback people have given me. Thanks so much again for joining. I really appreciate it. And we